Okay, so let's start. So among all the lessons that I've done with you up to now, this is going to be your most important lesson, okay? Because it summarizes for you all the things that you need to know.
So the most important.
Up to now, at least until this point, okay? All right. So the very first thing I want to say to you all is, I will start with the topic of ratio. Now, many of you here, you are used to using the ratio method. And whether you use the ratio method or you use the model method, actually it's the same thing. It's just different ways of representing the same thing. So if you don't understand what I'm saying in terms of the ratio method, you can use the model method to do it as well. All right? Let me just move all the screens aside. Okay, so in general, for ratio, there are 5 types of questions. The first type of ratio question is known as one variable unchanged. Okay, this is the simplest kind of ratio question where if you got A and B, A stays the same, B changes. The second kind of question let me just resize everything. All right. The second kind of question is known as total unchanged. Okay, or unchanged total, as some of you called it. And the third kind is called difference unchanged. The fourth type is known as the cross method. And the fifth type is known as the set or grouping method. These are the 5 types of ratio questions that you will see. There are no other types. They all belong to one of these 5 categories. Okay, I'm talking about problem sums here. In one variable unchanged, you have A and B. So if I give you the ratio of A and B as 2:5, and then later, so this is start. Let me just start over again. If I have a start and then I have an end, and then I give you A to B, and I tell you that the ratio starts as 2:5, and later on, something is added to A, but nothing is added to B, okay? So A increases, only A. If only A increases, and then the ratio becomes, say, 4:7. So A is the item, so A increases. So if A increases, then A change and B remains the same. This means that 5 and 7 must be the same number. Therefore, you will multiply this to 7, multiply this to 5. As a result of this, both of them will become 35 units. And that also means that you must multiply the same number to the front. You will get 14 units here, 20 units here. The difference will be 6 units, and whatever this number is, 6 units is that number. This is one variable unchanged. It is the easiest of the 5 types. Okay? Now I'll go to the second type. Okay, why cannot clean? Oh no. Okay. One moment. There's one more person coming in. Chantel. Okay. Now I'm going to talk about the second type. Oh, I can't change it. All right. The second type of question is known as total unchanged. In a total unchanged question, it goes like this, is I give you, you give me. Okay, A to B, B to A, total unchanged. Second kind, shared present. Okay, 3 kids are going to buy a present for their parents. They will share it in a certain ratio. Okay, A is maybe 1/4 of B and C, and C is A is 1/4 of B and C is 3/5 of A and B. That kind of question. They will share money to buy a present for their parents. This is total unchanged. Another kind of total unchanged is if A increases and B decreases by the same amount. They may not give to each other, but for example, if I give you a ratio of A to B, and then I say to you that A bought 20 more and B spent 20, then the total is still unchanged. So this is the third kind of total unchanged question. Having said that, I want to add on that for shared present, you can also have a shared age question. A shared age question will look something like this. The ratio, let's say A is 1/7 as old as B and C, 2 other kids, right? And then they say to you that the ratio of C to B and A combined together is 2:5. This kind of question is total unchanged because their total age, no matter how you add it, will still be the same. So it can be a shared present, it can be a shared age, shared total age. Do you understand so far? Okay, so these are the possible total unchanged questions. How do you do something like this? So what you need to do in a total unchanged question, a simple version of it will be this. Okay, A is to B, and then we have start and end. And then here you need to put total. So whatever number I give you here, for example, I say 2:7. And then I tell you that A will lose something or B will lose something to A. As a result, the ratio becomes 3:5. So the first step, your first step is to find the total. You take 2 plus 7, 3 plus 5, and then you cross multiply so that they both become 72. After that, you will multiply the number that you used to each of its parts. So here you times 9, you will also multiply this by 9. As a result, this will be 16:56. This one will be 27:45. For all total unchanged questions, you should see this. You should see that the amount of the increase here will be the same number as the amount of the decrease here, plus 11 minus 11. If these two numbers do not match, you have done something wrong. Is this clear?
Yeah.
Okay. So that's for total unchanged. Now we go to difference unchanged. For difference unchanged, as the term suggests, it means that the difference remains the same. And what are the types of difference unchanged questions? Again, there are 3 types. The first one is known as same increase. The second one is known as same decrease. And the third one is each question, but over past, present, and future. In other words, any kind of age questions that involves 10 years ago, 15 years later, this kind of questions with age questions is always difference unchanged. Do you understand? This one also has an age question, but this one is always present. There is no past and future. There is no 10 years ago, no 15 years later. This kind is total unchanged. This is how you differentiate. Let me remove this to prevent confusion. Okay, so we focus on this now. If we focus on this now, then this is what you need to know. If I give you two persons, A and B, again, we have start and end. But this time, we know that it is a difference unchanged question. So instead of writing the word total, I write the word difference. So let's say I give you now the ratio of A to B as 3:7. And then later on, I say to you, let's say they have the same increase, okay? They have the same increase. And they both received, say, $200. As a result, the amount of money they have now is 4:5. Okay? This means that the original difference is 4. Okay, maybe I don't use 5 because that's too easy. Let's say I tell you 4:9. Okay, 4:9. So we know now that the difference between these two is 4, and the difference between these two is 5. What you need to do again is make these two numbers the same, just like what we did with total unchanged. We always start from here. So what we got to do now is we got to multiply this by 5 and by 4 so that they both become 20. Again, whatever you do here, you also have to apply over here. What you do here, you also have to apply over here. This is the reason I always leave a gap in between. It is for you to write the new numbers. Understand?
Somewhat like making the denominator of a fraction the same.
In a sense, it is. Right? So now I got 15 units here, 35 units here, 16 units here, 36 units here. Just now remember I said to you, if you find that the number you increase and the number that you decrease has to be the same, if not, it is already wrong. Here, you will notice that this is actually +1, and this is also +1. They are, again, the same. If these two numbers are different in this kind of question, that means you already did it wrongly. Okay, so for these two, the number here must be the same. If not, redo. You are already wrong. Okay? So this is for difference unchanged. Now I come to the, so for same decrease, it is the same working. Age over time, still the same working. No matter how the working is the same, okay? As long as you found the category, then you know that the question is that. So actually, the most important thing to know is what type of question it is, not how to do the working. You must first determine which category and do accordingly. Now we go to type number 4. Type number 4 is cross method. Cross method is different from the first 3 in what way? It goes like this. If I give you A is to B, and I give you a ratio, 3:7. And then I say to you that A bought another 30 and B spent, say, $40. Now, these two numbers are not the same. So if they are not the same, then what will happen is you will have to put something like this. Let's say this is 30 toys, and this is, oh, you can't spend 40 toys. Let's say you
change it to dollars, I guess. Like the toys to dollars.
Let's say sold, okay? Sold. How about sold? Okay, sold 40 toys. All right. So now A has to increase by 30, but B has to decrease by 40 because this is sold. In a question where these two numbers do not match, it is cross method. Even if the word here is also bought, and this is plus 40, it is still cross method. Cross method is used whenever the two numbers do not match. Okay, this is how you recognize the question.
Also,
In this case and in this case, the numbers will match. Okay, remember, the numbers are always the same. But in this category, it does not match. Okay, let's go back a little bit. So what happens after you do this? They will normally give you the end ratio. They will give you the start ratio. They will give you the end ratio. The end ratio may be given as a fraction. For example, they may say that in the end, A is, okay, let's just get this right, 40. So A is 5/12 of B, okay, for example. They may say something like this. So if they say something like this, then now this is 5 and this is 12. So what you got to do at this point is you got to take these numbers here and you will need to multiply it to 12. And you will also need to take these numbers here and you will need to multiply these numbers to 5. Keep in mind that these are considered units. These are not units. Okay, in this case, these are toys. Right? Okay? So what will happen in the next step is you will take 3 units times 12, 30 toys times 12, 7 units times 5, 40 toys times 5. And they will be equal. Wait, I think I made a mistake somewhere. That's why the numbers don't make sense. I think I will increase this number to 49 plus, okay, can. Okay, let's change this number a little bit. Or maybe I decrease this one a little bit. Let's increase this to 9. 9, 3, 27. Okay, now it will make a bit of sense. Okay, so because I'm just picking up numbers from the sky now, so I just gotta have to change it a bit so that you don't, think that how come it doesn't make any sense. All right, so let's say I tell you that this number is 9. Okay, so if this is 9, of course that means this is 5, 9, and 3 times 9 will be 27 units. 30 times 9 will be 270. Okay, so now we end up with this, right? What does it mean? When you draw a model after this, your model will look like this. Okay, your model looks like this. And your first model here will be 27 units. Your second model here will be 35 units. These two numbers, you put it inside. And then you need to extend it by the number behind. Why extend it? Because they are equal. If they are equal, they will extend to the same total. So the next thing I'm going to do is I'm going to extend both of them. When I extend these, they will look like this. Extend this and this. And they will stop at the same place. Okay, this number will be 270. This number will be 200.
actually how is it supposed
Yeah, so what you got to do is you got to take 35 minus 7, and then you got to take 270 minus 20 to get the same portion here. So 35 minus 7, here it will be 8 units. 270 minus 200 is equals to 70. And then you start from there. Okay, again, the number here is not divisible because I'm just plucking out of thin air, right? But in the exam, this number will be divisible. Okay? All right. So that is called the cross method. So again, why cross method? Because of this. We are cross multiplying.
So is what do you call it? Is it common?
It is very common. It is very, very common. It will surely come up for your exam. So you must make sure you know this. Okay, let me tell you something, okay? Just within this category alone, you will see, for certain, you will see this question, 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 you will see this question.
Oh yeah, because it took out the other topic, so it's going to be mainly occupied by these questions.
That's right. Each of these questions will appear. One moment, something went wrong. Let me just move.
I've heard of only 3 of these methods.
Okay, so you will surely see all of them, but they may not appear all of them in paper 2. Some of them might be paper 1. Okay.
Like the first 3 might be in paper 1, right? Like
yeah, especially the first 3, because normally the last 2 are the ones that are more complicated. All right. Okay, let me erase. Oh yeah, wait. One last thing before I erase this. I want to tell you one more thing, which is very important. Once you found what is 1 unit, if I ask you, so what is A in the end? Listen to me. If I ask you what is A in the end, do not take the answer for 1 unit. Okay, let's say 1 unit is 10. Do not take 10 times 5. It will be wrong. You have to take 10 times 3 plus 30.
because the toys
It's not the same thing, okay? It's not the same because this is units and this is not units. That is why you cannot multiply the answer to this.
How many marks would this be worth? Any idea?
Sorry, what do you say?
How many marks would this be worth?
It depends on how they set the question. Sometimes they can set this question within another question. Then it will become a 5-mark question. They can combine it with something more complicated. You know, for example, I can combine this with an assumption question.
Yeah, I was thinking.
Yeah, then this will become a 5-mark question. All right? All right. So that's it for cross method.
I'm actually surprised. I'm only hearing of the last 2 now.
Now I'm going to talk about the last one, which is the set or grouping method. The set or grouping method works like this. An example will be A is to B. Okay? Or maybe I give you an exact question, like for example, I have boys is to girls. During a fun fair, a class of students were asked to sell balloons. In this class, there were 11 boys and 18 girls. Each boy was required to sell 3 balloons, and each girl was required to sell 5 balloons. Okay, I'm not being sexist here. Okay, this is just a story. Okay, so now if each boy sells 3 balloons, they would have sold a total of 33 balloons, and the girls would have sold a total of 90 balloons. That's 123. So I now say to you that they sold a total of, let me just get a calculator.
Like 193 times 5, I guess.
Let me just multiply by a random number. Say, okay. So on that day, they sold a total of 2,091 balloons.
Then you find the number of sets, then multiply by the number of, they ask you to find the number of sets.
So yeah, so the question becomes, how many, it can be many questions. I'll tell you how to do that later. So the first thing you do now is you need to form one group or set. Okay, they're just different words meaning the same thing. One group is made up of 29 children. One group is also made up of 123 balloons. And then now I ask you this. If there were 2,091 balloons sold that day, how many girls were there at the fair selling balloons? So you will take 2091 divided by the number of balloons in one set. Now remember that these two words must be the same. If you end up putting balloons over children, it will be wrong. Okay, they have to be the same units. This will give you 17 groups. So now I can ask you anything I want to ask you in an exam. I will ask you, for example, how many boys were there? You will then take 17 and you will multiply 17 to 11. If I ask you, how many girls were there? Your answer will be 17 times 18. If I ask you, how many balloons did the boys sell? Your answer will be 17 times 33. If I said, how many balloons did the girls sell? It will be 17 times 90. I can also ask you, how many more balloons did the girls sell than the boys? In that case, I will take 90 minus 33 times 17, and so on. Okay? This is called the grouping or set method.
Wait, can I know this method as number times value.
But the word number times value doesn't have a lot of meaning behind it, doesn't it? You think about it.
Like it's kind of the ratio.
Doesn't it make more sense if you call it a grouping method?
I call it number. I'm used to calling it number times value.
I mean, you can call it whatever you want, as long as you understand what I'm saying, okay? All right, let's move on from here. Okay, I mean, as long as you're comfortable, it makes sense to you that that's a perfectly good thing, all right? Okay, let me move on. And
like grouping method is 4 marks, 5 marks.
It can be 3, 4, or 5. It depends on how complicated the question is. Okay,